So today we're going to start solving using logs and exponentials and natural logs and all that fun stuff. Math today. Tomorrow you're going to take a formative in class on 3.1 to 3.3. Then Tuesday we'll come back to solving type stuff, and then we'll start reviewing and all that fun stuff for your test, which your test looking forward is the 12th. So it's a week and a half-ish. Last day of September already. Ay, caramba. Okay. So when you are solving, you always need to remember this, that when you're in exponential form, the top one is exponential form. Okay, you've got the base with an exponent, and that equals what we call the argument. Okay, so that's exponential form. If you're going to solve an exponential, you got to put it in logarithmic form. Okay? And so the logarithmic form then would be log of that same base of the argument equals this. If you're in logarithmic form, if you have a logarithmic equation, you got to put it in exponential form in order to solve it. They're inverse functions of one another. Exponential is an inverse of logarithmic. It's kind of like the same as if you were adding. If we had x plus 2 equals 7, you would subtract 2, because subtraction is the inverse of addition. And well, these are inverse functions, just like adding and subtracting are inverses, or multiplying and dividing are inverses. Okay, so these are inverse functions. Very important slide. Make sure you got this one. I'd even put a little box around it or a little star next to it, or maybe two parts. Okay. Get all crazy and put like big time stars around it. Yeah. It's a 6-star review. All right, so let's do this. So the first thing that you've got to do, okay, whenever you're solving one of these type of equations, is it's just like if you were solving an algebraic equation. You want to get your variable by itself. Okay? Well, our variable is going to be located in the exponent or somewhere in a log. Okay? So we still need to get that by itself. Okay? We still need to isolate that variable. So what I'm first going to do is I'm going to have to subtract 4 from both sides. If I do that, if I subtract 4 from both sides, I get 3 times 5 to the x power equals 16. Still don't have my variable by itself. I can divide by 3. To the x power equals 16 thirds. Okay. Now I've got my variable isolated. Okay. It's still not just x equals, but I've got nothing but that variable on that one side, or that variable locked in on one side. So then what I can do, so first off, first step, we got to isolate. Second step then is we got to switch. So we're in exponential form right now. We've got to switch to logarithmic form. So this would become log base 5 of 16 thirds equals x. And then we can solve. So now this one, we're going to use change of base formula on it. Okay. So I'm going to take the log base 10, or the natural log, one of the two, of 16/3, and I'm going to divide it by whichever log I chose of 5. Clear. What's the natural log of 16/3 divided by the natural log? And I get here, I'll write out many a decimal point, 1.0401000038. Yes? What's up? Okay, so you're gonna, can you see what you're typing in? But like, does it give you a line of what you're typing in? Okay, so then you would go natural log of open parentheses 16 divided by 3. Well, okay, 16 divided by 3. Let's do it in the right order. Then make sure you close your parentheses. Then hit divide. Then hit that log thing again, and then do log 5. Okay? It said way up in the far corner that we should round our answers to 3 decimal places if necessary. So I would go here 1.040 is equal to X. We can always check it. We can always go 5 raised to the 1.040 power, then times 3, then plus 4, and I get 19.997424113, but that's because we rounded. I would have done it exact. I would have done the answer. Okay? Love it. You try that one. Actually, let's try this one together because it's a different thing. What would you do first? Subtract 7. Do we all agree with subtracting 7? Okay. Now what? Divide both sides by -3. Love it. Now what? That's you. Now what? Now we got it trickier, right? Because what should we do? Switch forms now, right? Okay. Well, what's log base E? Natural log, right? Yep. So this is just natural log. Instead of writing log, we're going to write natural log. Okay? Instead of writing log base E, we write natural log. What's my argument? 5/3. What's my exponent? -x, right? Okay. So we can take, now on your funky calculator, I think if you go in that log, if you scroll down, I think that's where you get the natural log. Natural log of 5 divided by 3 gets me. So if I do, so this then would be negative natural log of 5/3 equals x. So I get negative 0.51082564. It said round to 3 again. I would say negative 0.511. checking it. So 7 minus 3e to the negative, well, we can call it positive, 0.511. Gets me, I get 1.999128. Questions, comments, concerns, clarification? Okay. Try this one on your own. Yep. Subtract 3 first. That gives me negative log of 4, or log base 4, of x plus 2 is going to equal positive 2. Divide both sides by negative 1 gives me log base 4 of x plus 2 equals negative 2. Flippity floppity forms. Okay. Flippity floppity forms would say then that we would have 4 to the negative 2 power equals x plus 2. Right? 4 to the negative 2 power is 1/16. If I'm going to subtract 2 on the right side, I'm really going to subtract 32/16 on the other side. And that gives me negative 31/16. Checking it back in my original equation, negative 31/16 plus 2 is 1/16. Log base 4 of 1/16 is negative 2. 3 minus negative 2 is positive 5. Yes? Now, had you given this one to me, because the directions at the top did say round of 3 decimals, we would also accept here negative, oops. It did say way back up here at the top, round of 3 if necessary. So, when we've got 2 logs, we first have to combine them down into 1 log. So we have to use our properties from yesterday, the expansion, the condensing, all that fun stuff. Okay? So this one is going to be, first I'm going to apply the power property. Log of x minus log of x plus 4 to the 1/2 power, and that equals 1. Then I'm going to apply the quotient property in reverse. Log of x divided by x plus 4 to the 1/2 power equals 1. Now that I've got it down to a single solitary log, that is isolated. Now I can switch forms with it. What is the base on my loss? 10 to the first power equals x over x plus 4 to the 1/2 power. This be square root of x plus 4. Okay, right. In fact, I'll do that right now. How am I going to solve that? Square root of x plus 4? Yep. Okay, yep. So then I get 10 here times the square root of x plus 4, and that equals x. Square both sides? We can do that, right? Okay, let's do that. We can do that. That gets rid of the square root. Okay. Left side squared. 10 squared is 100. X plus 4, or the square root of x plus 4 squared is x plus 4. And that equals x squared. It is a quadratic function. Yeah, it is. So what should we do? Is it factor? I don't think it is. Two numbers. Well, so first off, we should probably get everything on one side. Okay. I don't think that there are two numbers that multiply together to be 400 or negative 400 and add together to be negative 100. So that leaves us with completing the square or quadratic formula. Okay? Or we could graph it. That way too. Okay? So let's go old school. So opposite of b is going to be 100 plus minus square root of 100 squared minus 4 times a, which is 1, times c, which is negative 400, all over 2 times a, which is 2. Okay. So 100 here plus minus the square root of. So that's what, 10,000 plus 1,600? Right? Well, right? 10,000, right? Negative 1,600, but minus negative 1,600 is plus 1,600, right? So that's 11,600. Just as a side note, 11,600 is 400 times 29. Why is that important? Did you say, yep, square root 400? Yep. So this is 100 plus minus 20 square roots of 29 all over 2. So x here is equal to 50 plus minus 10 square roots of 29. Okay? Now, let's check this. 50 plus 10 square roots of 29 is 103.85, oops, 85, that should be a 5, not a funky number. 852. Minus is negative 3.852. Okay? If we go way back up here, my first check would be in log of x. Because this was log of x minus 1/2 log of x, was it plus 4? Yeah, plus 4 equals, what did we say, 1? 1? 1? Okay. So if I put in log of 103, I can find that. Okay. Log of 103, that works out, that gives me a positive argument. Still get a positive argument when I plug in that one. Okay. But if I plug in the negative one, log, can somebody on their calculator find for me what log of negative 3.852 is? What do you got, TC? Error. Domain error. Error. Okay? Syntax error. So this one right here gets thrown out. It's extraneous because we have to have positive arguments all the way through. So the only answer here would be x equals 50 plus 10 square roots of 29, or approximately 103.85. And just a quick check. Log of 103.852, close parentheses, minus 0.5 logs of, what's that, 107.852 gets me 1.0000000076. That was the last one. Oh, my Lanta, there is one more.
That is the
Two.
last one that we expected to get.
This is where we didn't get to?
Yeah.
Perfect. Good timing. Natural log. Yeah, let's do this one. We'll do one more. We'll be extra.
Oh, yeah.
Yeah. Yes. Yes. Good so far? Good so far? Now what? Switch form. What's my base? E. Okay. So my base is E. Exponent, 1/3. Argument, x minus 3. So then I'm going to add 3 to both sides. 3 plus e to the 1/3 power equals x. Now, if we were asking for exact answers, that would be our exact answer. A cube root? No. No. Well, because it would be cube root of just e. I mean, you could. Like, you're saying like this? Like that? That's fine. I mean, I would accept it, but it's just the same here. Yeah. Yeah, just because e is kind of special. Yeah. 3 plus e to the 1/3 power. I should have wrote it down the first time I did it. I get here approximately the 3 decimal places 4.396. Yes? Love it.
Okay.
Love it. I like the exact better, but